Hi everyone, it's Mr. Cardoso again, and we are continuing our lesson on the introduction to objects. We're back here with our class fractions, which we started last time. We created a class fraction with an int field and an int num field for the numerator and a den field for the denominator. And they're both of type integers of a fraction. So notice again, there's no main method inside here. There's just two integer values, which kind of defines what this object will be. And then we went over here and we created a fraction calculator where we created a couple of fractions. So on the right here, these are a couple of things I want to cover in this lesson: the difference between declaring and creating an object. Later we'll talk about the equality of objects versus primitive data types. When I say primitive data types, think int, double boolean. And our first instance method, we'll do that here in this lesson as well. So here we've created two fractions, right, called f1 and f2. So like I said, this class here defines it's like the cookie cutter, so it defines what each fraction is going to be. And then anyone who makes another class, any other programmer who uses this first class, can use all of that functionality. So now I can declare two different fractions, or I can declare hundreds of fractions. Later on, we can even declare arrays of fractions. And each one will have their own numerator and denominator. So to visually understand this, let's first do this. And in fact, this time I'll use the interactions panel down here. So I'm just going to scroll up here. So I can create a fraction and call it, just like, for example, let's go back here and I can go int, x, let's say, and I can declare x as an integer. I can do the same thing now with a fraction, because actually what I should do, you see there's a little star up here, so I should compile that first. Okay, so I can declare int x, I can declare fraction f, right, for lack of better word. In fact, I'm going to call it f1, and I can do that. Now, when I create fraction f1 here, visually on this side, get out of here, what I'm going to do is I'm going to create f1. So this is like a diagram of what's happening in memory. And f1 is actually not pointing to an object. Sorry, let me erase that. F1 is pointing to this symbol. Basically, this represents null, meaning nothing. Because we've declared F1 as type fraction, but we haven't actually created the fraction. So now to create a fraction, like I said last time, objects are not like primitives in the sense that you've actually got to create them using the new keyword. So you got to go F1 gets new fraction, open close brackets, semicolon, and now instead of pointing at this, F1 now, so let's cross that out, funky pen there, F1 now points to this fraction object. So we like to represent objects as boxes, and we put the fields inside. So this is the numerator field, and this is the denominator field. Okay, so right now these kind of default, these are both integers, so they default to whatever they are. Over here we could actually do that all in one line as we saw last time. So here we declared it, and then we actually created it on this side. So here we can do that all in one line with fraction f2 as we did last time. Sorry, equals new fraction, open close brackets, and that will do it all in one line. So that creates f2, and that points to another fraction like this. Now, over here in the interaction panel, I can assign values. This also has its own numerator and den field, right, for this one. So we've got two, these are called instances, okay? So these are called instances of the fraction class. So I can make them in the interactions panel. When I'm working in the interactions panel, it's basically like I'm working in another program that's using the fraction class. Okay, so I'm outside of this class right here. So I'm within another class using that class. And so now these are instances. I can assign values to each instance. So f1 has its own numerator and denominator. f2 has its own numerator and denominator, like I said last time. So f1.num I can set to 3. Let's say, so now what that does is that'll put a 3 in f1's num field over here. And then I can say f1.den gets 4. And that'll put a 4 over here in the den field. I can say f2.num equals 1. That'll put a 1 over here. And f2.den equals 7, let's say. And that'll put a 7 over here. So what's clear, what I want you to see very clearly here, what we're doing is, even though there's only one, we've only declared one integer numerator and one integer denominator. We've only declared one of those. But because it's a type, each instance, so f1 is an instance, f2 is an instance of this fraction class, they have their own numerator and denominator fields. Okay, any programmer who's now using this class can make any fraction they want, give it any name they want, that's just a variable name, and that fraction will have its own numerator and denominator field. So there's basically infinitely many fraction objects or instances that can be made from this class. Now, to go back to this point, difference between declaring and creating an object. So we did that there. So make sure, this is declaring it, but you haven't created anything. So let's just go back and see what happens. So if I create fraction, let's say f3, and I type f3 here, it points to null. So this is our null thing here because we haven't used the new keyword to initialize it. Hope that makes sense. Now, let's go to the next point here, which is equality of objects versus primitive data types. So primitive data type, what's a primitive data type? Let's say integer. Integers, doubles, booleans, chars, they're all primitive data types. Okay, they're not objects. Basically, any data type that starts with a lowercase letter is a primitive data type. So let's make two integers. You know what, I'm just going to reset this right here. So let's make two integers, so int x equals 5. Let's say int y gets 4. Sorry, let's say it gets 5 as well. Actually, let's say it gets 4. Okay. Now, if I say x equals y, and equals in Java is the way to check for equality, so it gives me a true or a false if they're the same. What do you think this one's going to say? Hopefully you said false, because they are not the same. Now, if we say, let's say y gets 5, now x and y are both 5. So if I say the same thing, hopefully you will see that that's a true, because they're both 5. So it's saying, well, yeah, they're the same value. So let's try this now with objects, and we'll use fractions to try this out. So let's say fraction f1 equals new fraction, let's say 3, 4. Sorry, that's for later. So we go f1.new equals 3, f1.den equals 4. Okay, so let's go to that diagram. So we've already got that here. On the right hand side, we've got 3 and 4 for f1. And let's change this one. So I'm going to delete that. Oops. And for f2, I'm actually going to give it the same values. Okay, so I'm going to go f1 dot, or f2.new gets 3, and f2.den gets 4. All right. So now what that does is it puts a 3 here and a 4 here. So if I check for equality, they both have the same values, just like the x and y both were 5. What do you think it will say? So if I go f1 equals f2, what do you think it will say? It should say true, right? Because they're both 3 over 4. But it doesn't. It says false. And so because with objects, like they're different than primitives, it's not just checking the values for equality. It's checking to see if they're pointing at the same object. And so, for example, if I were to go system.out.println f1, okay, what does that print out? Prints out, and remember last time I was saying that basically this is the fraction class, and this is its unique identifier for f1. And if I do the same thing for f2, you can see this is the unique identifier for f2. And because these two are not the same, they're stored separately in memory, they're not the same fraction, so that's why it returns false. The only time that this returns true, if you want to get it true, is if you actually make it point at the same fraction. So we'll do that now. So let's say, for example, I went fraction f3. Now this time, I'm not actually going to use the new keyword to create f3, right? So f3 is pointing at null, right? Just like this original diagram up here. So let's draw that. f3 is pointing at null. That's our symbol for null. So what happens now is we can take f3 and we can go f3 gets f1, let's say. Right. So that works because they're both a type fraction, so I can assign a fraction to another fraction. They're both fractions. So what this does is it says f3 gets f1. So this crosses out that arrow, and it says f3 now points at f1 over here. So when f3 points at f1, they're both f3 and f1 are both pointers pointing at the same object. Right, so now if I go f1 equals f3, you guessed it, we get a true because they're pointing at the same unique identifier. In fact, if I print out f1, I get that unique identifier. What if I print out f3? I get the same unique identifier. And that's why when I check for equality, they're the same. Okay, it has to be pointing at the same object. So it doesn't matter what the values are inside in the fields. The unique identifier, basically it's got to be pointing at the same fraction object for it to return true for equality. Okay, so in the same way, now I can also go f3, let's say I go f3.num gets 1,000. Okay, well now if I wanted to, what that does, it'll go f3's num is 1,000. Does that change? So that goes up here, f3's num is 1,000. So that changes f1's num as well. So if I went f1.num just to see what it is, or printing it as system.out.println, I also get 1,000. If I go f3.num, I also get 1,000. All right, so I'm going to leave it there for now. I'm actually didn't get to this last point, our first instance method. I'll get to that in our next video where we'll talk about instance methods. Thanks for joining me this time. Bye.